Come on, start. Okay, recording is started. So welcome to today's tutorial. We're going to continue with the 2023 past paper, right? So let's go to the document. Okay, this is ComSci 2A. It's this folder. I think it's paper A, right? Yeah, we're doing paper A. So I'm gonna open the PDF. Yeah, so we're still doing the allocate function, right? So let me open it. The code. So there's my code, and then I'm gonna go to view, manager, sources, mist.cpp, mist.h. Yeah, so this is the allocate function. So if you remember the allocate function, right? It's basically the initialization function where we do our initialization. So all the things you must take in from the user is equivalent to the number of parameters that are required for the allocate function. So we needed to pass in the size of the world first, followed by the probability and of a battery, and then the probability of an exposed wire. And we had to pass this via command line arguments, right? So we've declared command line arguments. We should be sorted with that. I think I did. Did I declare them? Okay, we're gonna look at that later. But I did explain command line arguments that I remember. And let me continue. Yeah, I need a moving function. So we have allocate and deallocate, right? So those are the functions that we have. So let me see, moving, update. Yeah. So we're gonna need a destroy or deallocate function, an update function, and a move function. So let's just simply implement the move function, right? So the move function moving, the operator can move in any direction, including diagonal movement, right? So let me open Notepad plus. Okay, so this is in ComSci 2A. So let me remove that. So this is the notes that we wrote yesterday, right? So I'm gonna leave that there for now. Okay, we have yeah, direction. So when it comes to movement, right, in a game, you can move in multiple ways. So you can move let's start with move up. You can move up, you can move down, you can move left, you can move right, right. Then you can also move up and left, right. You can also move up and left, and you can move up and right. Then you can also move down and left, and you can also move down and right. So this movement, starting from the one that have an end, this is what we call diagonal movement. So what do I mean by move up and left, and move up and right, move down and left? So let me demonstrate that using the paint program. So let's say this is you over here, right? And you want to move to this location over here. So to move to that location, we call this diagonal, right? To move to that location. That's diagonal, right? Okay, I know this person doesn't mute as expected. I know this person has a tendency of not muting. So minimize that. So this is diagonal, right? So imagine this is you, right? You want to move to this location over here, right? So you want to move diagonally, right? So let me see. Let me make it. Another diagram here. So dot and then X, right? So how do you move there? To move there, you can actually move in one of two ways, but you notice that you're moving in the same direction. You can move down, right, and then move right, which is technically the same as like moving from here to there. right? So it's like technically moving from here to there, but then you decided to do it this way, the long way, because in a computer, right, you can't really represent this movement over here. That doesn't make any sense. So you can actually only move this way. That's why I have those movements. Move down, and then after moving down, you move left or move right. In this case, we moved down and also moved right. So yeah, we can have this. These are our game movements, right? What I would advise you to do, right, when it comes to your game movements, is to actually create an enum to represent to store this as constants, right? So, for example, I can say move up is represented by the number 0. This one is represented by the number 1. This is represented by the number 2. This is represented by the number 3. This is represented by the number 4. Move up and left, blah, blah. Okay, this is represented by the number 4. This is represented by the number 5. This is represented by the number 6. And then there's 7, right? So as you can see, these are just constants, right? Basically numbers that won't change. We could create an enum for that, right? But then we don't, I think you guys are not allowed to create an enum yet. You haven't been taught. So we're going to just create them as constants. Remember, we talked about constants. So I'm going to say constants for my movements. So these are the constants for my movements. So and if you check something, right, what is the data type of each value? It's an integer. So I'm going to say const int. So const int move up is equals to 0. Then we're going to do all the other movements. So let's do that. So move up, move down, move left, move right. Then we repeat this again. So we have 4 more. So we have move down, left, right. So move down. To be honest, it doesn't matter in what order you put them in, because the main important thing is that they have a different integer. Move down, move left, move right, and then move up and right. Then you have move up and left. Do you start with left? Let me check. How did I name it? Oh, I started with left. So move up and left. I start with left. Then move up and right. And then move up or down. Move down, move down and left. Then move down and right. Then I change the integers. So this will be 1, 2, 3, 4, 5, 6, 7. Right, so these are my constants that represents my movements. So this just represent the movements. So I'm gonna leave that as it is. So these are the movements. Then we go back to our question paper. So we have moving. We're done with the initialization part, right? Just the function prototype, not the implementation. So we have the moving section where we need to create a move function. I'm gonna call it move player, but what is the actual player here? It's a operator, right? It's the black circle. You see, it's the black circle. So I could call my function move player. That's still fine, but we don't have a player here. We have an operator. So one of the Utopia power plant operators managed to navigate to the power plant to try and fix the power outage. The power plant is also covered by the mist, and the operator must find the main switch. So the one who's doing the movement here is the operator. Because the question here, you see that it says the operator must find, meaning that the operator moves, he walks around. So therefore, I need to move. I need to name my function move operator. And it's going to be, like I said, most of these functions are going to be void. So void move operator. Mm, yeah, we just say that it takes in a movement, right? I'm gonna say it takes in a movement. So int movement. Basically, in what direction do you want to move? It takes in that movement. Oh yeah, basically the direction. Yeah, it's the direction. Why am I, you might ask yourself, right? Why am I passing an integer? Because we have integers to represent our movements. So that's why I'm passing an integer here. You could also still make it const int. That's fine. There's nothing wrong with that. Const integer because it's constant. It's not a number that we're going to change. So I'm just gonna leave it as const int there because we're basically passing constants. So that parameter will never be updated inside that function. Then let's see. We have that move operator function. Then we need the update function. So the mist around the operator must be updated as follows. So we need an update. The region of the world within one block radius around the operator must be visible since the operator is carrying a torch. The radius, right? They mean the circle, the bigger circle with the black line. And then the rest of the world that is not within one block radius around the operator must be covered by the mist. Okay. If the operator moves to the same direction as the main switch, the entire world must be made visible. So you see, if you notice something here, right, they say the region of the world, they say the rest of the world. So we're dealing with our game world. So we need to take in a pointer. So it's going to be called void update, which takes in our two-dimensional array, right? And we've given it in a different name or something that we call a type alias. So I've given it that name. So type dev, it's now called 2D array. So I'm gonna pass that data type there. So 2D array. Let me call it game world, because it represents my game world. And this array is going to obviously have certain number of rows and columns, right? So I need to have those, I need to pass those. So int pass int rows, int calls. But most of the time, we're not going to change these parameters, right? Yeah, won't. You can't change the size of your game, so we will actually pass them as const int, meaning that they should be constant when they're passed. They can't be changed or modified inside the update function. We need to update our we need to update our 2D array game world. That's why we're passing it there, and it has a specific number of rows and columns. So we need to also pass the rows and columns. Why are we passing the rows and columns? If you check inside the namespace, right, I didn't declare them, the rows and columns. We are just receiving them from the user. Then I'm gonna go back here. The game ends in victory if the player moves to the, yeah, that's fine. You see, they're talking about movement here. We have a function called move up operate. That's where the end game code will be placed when we move inside the movement function of the operate. The function called move operator, which is this one. That's the function where we're going to put our end game state. Then after allocating, we can also deallocate. So void allocate. To deallocate, right, we don't actually need the size. I only need the array itself. So 2D array. I'm just going to call it my game world. And then, yeah, I think that's pretty much it. So let me check. Do I need any extra functions inside my header file? Yeah, there's no extra functions needed. Unless in the future we see that we end up needing some functions. But for now, we don't see the need. So we just simply copy this whole namespace. Okay, when you copy the whole namespace, right? When you're doing implementations, you don't have to copy the types. You see these constants and everything. You only copy the functions because we want to implement the functions. So I'll still copy everything, but I'll delete all the variables. So copy, go to my .cpp file, paste everything, and then delete all the variables. You inside your CPP file, right? You only put in the functions because you want to do function implementations there. Then you replace the semicolon with the curly braces. and then semicolon with the curly brace, semicolon with the curly brace, right? So these are our functions, right? So let's do memory allocation, right? Let's do initialization part. Yeah, I think we might spend a bit of time there in the initialization. We'll see how far we go. Excuse me. So we start with the number of batteries, right? Probability, blah, blah, empty. Okay. Let me see. The size of the world, the probability of a battery, and the probability of an exposed wire must be provided via command line arguments. And then the world is filled in the following order. The operator starts at the random location. Random. You see, there's randomization here. So that means we need to have a function that generates the random integer because they said a random column at the bottom row of the world. So we need to generate, and the column is stored as a type integer, right? So that means we need to have a function that returns a random integer. So let me go back to my code. Since this function won't be used inside of my main.cpp, I don't need to declare it inside the header file. I only just go to the cpp file and start implementing it. So I'm going to call it, it's going to return an integer because we're generating a random integer. Call it generate rand int, right? Or gen rand int, which generates a random integer. And it takes in two parameters, right? The upper bound and the lower bound. So int, okay, I'm gonna always start with the lower bound. So lower bound, int upper bound, or you can say mean or maximum and maximum. That's up to you. I like to call them bounds. So I'm gonna say have lower bound and upper bound. You could have this as min or minimum value. This is max or maximum value. But then I wouldn't advise using min or max because it's already reserved in C++ for something else. You see, it changes color, meaning it's already part of C++. Come up with a different name. Then to generate a random integer, we need to find its range, right? We talked about this in our sessions. We're gonna say the range is equals to the upper bound minus the lower bound, and then you add 1 to that. Then you return the range modded by return the rand function, not the range. Return the rand function, which generates a random integer, right? Then we need to restrict it to certain bounds by dividing it or by applying the modulus operator to it. So I need to include it first. So let me go to my header file. And then I'm gonna say hash include C time. We probably need to display the array. I forgot to do that. We need to be able to display the array. So void display. I'm gonna call it display, which takes in the same parameters as this. So because we need the 2D array, which has rows and columns, so we need to also pass the rows and columns. So this will be display world. Let me call it display world, right? Come on. And I'm gonna copy this, go back to my CPP file. I can put it anywhere. So let me put it here. Replace the semicolon with the curly brace. Yeah, that's fine. So since we're gonna need to display, we're gonna need to use the IO stream. So hash include, okay, let me put it underneath here. So hash include IO stream, right? And then I want to say using namespace. Okay, you don't have to say use namespace standard here, not really here. It's not necessarily here. You can use it inside the CVP file and say using namespace standard. You can do it there. It's up to, it's still okay. You can technically put it in here. There's nothing wrong with that. So we prefer to use it this way, to include it this side because this is where we use the C in and C out or C out. So yeah, and then since and the rand function is also part of the standard namespace. So let me see. Uh, okay, it's fine. Then I'm gonna say modulus divided by the range plus the lower bound. Then it's gonna give us a value within that actual range. Then we have the display world. So let's start with the allocation, right? So I need to be able to allocate memory for my game mode. Basically, give my game mode an initial state. So to give my game mode an initial state, I need to understand what's required in the preg. So I need to go to the initialization part. Now we're dealing with initialization, right? So the game mode, you have a size, the probability of a pattern, the probability of a exposed area. We are passing all those values, right? Because we need to initialize our game, which is our 2D array. So before we continue, right, we need to resize basically allocate memory for the pointer. Remember that our 2D array, right, is dynamic. So far, it's not given a size. There's no size. So we need to initialize it because now we've received the size from the user, which is rows and columns. So let's use those, right? So I'm gonna say int, no, not int. What is this? Yeah, what's my array called again? Oh, I have this type. Hmm. Let me think. Seems like I need to change a few things here. Let me see. Technically we could, but no. Let me not do that. Oh yeah, allocate. Yeah, yeah, yeah. To allocate, right? Because we need to after allocating, we need to get back the pointer or the array, the 2D array. So I'm gonna actually return it and say 2D array. I forgot to do that to there because if you look at the parameters of this function, right? Do you see them? It's only integers. So how will you get back a 2D array? By actually changing the function to return a 2D array. Since it's supposed to return a 2D array, we need to create a variable of type 2D array, and then I'm gonna call it array world, right? Which is my array that represents my world. Then I'll simply return array world because at the end of the day, after I'm done with everything, I must return my pointer or my 2D array. Then now to initialize the pointer, remember this is 2D array, this is the pointer. This part over here, right, is just int pointer, right? So let me do it this way. You'll understand why the code needs to be changed. So let's leave it like this. This is how it is, a two-dimensional array of integers, right? We need to instantiate it. Remember, each pointer represents a dimension. Since we have two pointers, that means that there's two dimensions. It's two-dimensional. So I'm gonna instantiate it or allocate memory for it. You guys, you're not taught OOP yet, so we call it allocation for now. So I'm gonna say is equals to new, and then remember I told you how to allocate memory. You say new to refer to the heap memory, followed by the data type of each element in the array, followed by a size in square brackets. Right? The size in square brackets is okay. Yeah, the square brackets provide the size of one of the dimensions. The way we're going to allocate it is we're gonna start by the outermost dimension, basically the second star or the second point. That's the one I'm gonna start by allocating. To allocate it, right, you're gonna say is equals to new int pointer because we're allocating for a two-dimensional array of pointers. Then to specify remember I said each pointer or each star represents a dimension. To allocate memory for each star, you replace that star with square brackets because that's what square brackets do. You use them to specify. That's one of the purposes of square brackets in C++. To allocate memory or to index into an array. So in this part here, we are doing the former, right? We are allocating memory into the array. So that means I need to replace one of the stars with square brackets. So I'll replace the second one because that's the closest one, right? So it's this one, which is the closest one. Replace that one with square brackets. I'm just going to initialize the two rows. So that means one of the dimension is of size rows. Then now I need to go through each of the rows. Why do I need to go through each of the rows? Because if you remember 2D array, right? It's basically this. Let me show you an example. So it's basically, let's say this is the 2D array, right? Let's make it short, just two rows and 4 columns. So this will be column column 0, column 1, column 2, column 3. And this will be row 0, row 1. So this is how the 2D array would look, right? So as you can see, there's a row 0 points to that collection, right? So let me put an arrow. This points to this, and then this points to that, right? So we have this. So this points that, this points that, and then this 0 index here, it points to the first column. It refers to the first column, which is a pair of these two zeros. So this is row 0, column 0 would be this. So row 0, column 0 would be this coordinate over here because there's a column is 0, the row is 0. So it's this coordinate over here. If you notice a pattern here, right? Each row has the same number of columns. As you can see, right, each row has the same number of columns. So that means that I need to create a, okay, let me put it as a comment, but then still leave it. Okay, let me just quickly put the comments there. Yeah. So that means I need to go through each row. Then each row, I resize it to be the same number of columns. So now I'm going to do a for loop. So for int I is equals to 0, I is less than rows because we're going through all of the rows. Then I plus plus to move to the next row. Then we need to allocate memory for each row. As you can see, at row 0, it has four columns. At row 1, it has 4 columns. So we need to allocate for each individual row. And each individual row is stored inside the variable I. So therefore, I'm allocating memory for my array world, which is this one over here, array world, right? So I'm going to say array world at index I. Why I? Because we're going to keep changing. We're going to go to position 0 or row 0, then go to row 1, go to row 2, and so forth. So I'm just going to put I there. Then it's going to be equals to new int pointer, right? So we've already allocated for the first pointer. So we can remove that. Now we need to allocate for the second pointer, which is the last pointer that's left. Remember, we said to allocate memory for a pointer, you replace the pointer itself with square brackets. Then within the square brackets, specify the size. So within square brackets, this will be calls because each row has the same number of columns. So that's why I'm passing columns there or calls. And this is a proper way of allocating memories. But we're not entirely done yet. There's a few changes we need to make. Remember, we have type aliases. We use type def. So these types here, they've different names. You can still leave it as like this, it'll still work, but then we already wrote those type aliases, so we need to use them. So everywhere where there's an int star, we can actually refer it to 1D array. So I'm gonna copy this, go there, and then I see int star here. There's int star. So I replace that with 1D array. Then I replace that int star again because it uses a different name in our application. So I replace that with 1D array. Then there's still this pointer here. So basically now our 2D array, right? It's a one-dimensional array, and then at each dimension it is another dimension. At each index it is another dimension. So basically 2 dimensions. So this is the first 1D array. The second pointer represents the second dimension or second 1D array. So this will be now 2D array. But then if you still remember, when you use type def, we actually defined a new name for this type. Let's go to a header file. You see, There's the header file. It has this type def. That means everywhere where there's these two things paired together, we replace them with this one word. So I'm gonna copy this, go to my mist.cpp. Then where I see 1D array pointer, I replace it with 2D array, because that if you notice something, right, this is what the function expects to return. That's why I used 2D array, because that's basically means int pointer pointer. So I hope that makes sense. So we're not done with allocate with allocate function, right? To allocate our world. So I'm gonna go to my document PDF, and then let's see what needs to be done. The operator starts with a random column. They said random column, right? So they said the operator starts at a random column of the bottom row. So how do we find a random column? A random column is, remember, indexes for arrays, they start at position 0. So if I have five columns, right? Excuse me. So if you have 5 columns, that means that the range of my indexes is between 0 and 4, to 0 through 4. Basically 0, 1, 2, 3, 4. Because arrays are 0 index, they start counting from position 0. So if I have 5 columns, it's like that. If I have 6 columns, that means it's from index 0 through 5. So 0, 1, 2, 3, 4, 5. Because I have 6 columns. So that means if you notice a pattern here, right? Do you notice a pattern? If I have if I have 6 columns, right, the last index is always the total number of columns minus 1. Look here, 4 is just 5 minus 1. 5 here is just 6 minus 1. So the last index, right, is always equals to a number of columns or number of rows minus 1. And we always start counting from, so starting index will always start from 0. So now I can use this and knowledge to my I'll use this knowledge in my practical, right? So let's go back here and see what we can do here. So let's see. The operator must generate a random column. So we need to generate a random column, meaning it's in between those ranges. So I'm gonna need to go here after the for loop, right? Because it's one number. So I'm gonna generate after the for loop, generate a random column. So I'm going to generate a random column, store it in a variable. So int, technically the random number you're going to get is going to be a positive number, because you always start from 0 and going upwards. There's never a negative index or negative position in an array. So I'm going to say column, or let me say random column, right? So this random column I'm going to say is equals to, remember we have a function to generate a random number called gen_rand_int. So this gen_rand_int function, it takes in 2 parameters, right? A lower bound and a upper bound. So what's the lower bound? Meaning what's the starting point? It starts at 0. And then what's the stopping bound or upper bound? It stops at exactly the number calls, the total number of columns minus 1. Because we did explain that the last index, it always stops at the total number of rows or columns minus 1. So this is how you generate a random column. Then that random column that we generated, right? Remember, our array is a 2D array. It means that when we want to place a character or a game character, we provide 2 positions, sort of like a Cartesian plane, X and Y. In our case, we have R and C, or row and column. So that's how we're gonna place anything into our array, because it's 2D array. So let's see the operator. So we need to place our operator. So remember, if we go back to our diagram, let's try to remember that. Let's go back to our diagram. Remember, we have integers to represent all of the symbols. So what I'm going to do, right, I'm going to copy this and then go to my code, put it as a comment. so that you guys can always refer to this comment when you're reading the code. So I'm gonna do this. Yeah, so this is the code. But before we generate the operator, or before we place the operator or the battery or all those things, before we place them into our game, what we need to do is we need to make sure we initialize everything in our array to an empty space, basically the integer number 0. So as you can see, these are also constants. 0, 1, 2, 3, 4. They're also constants. So why not simply go to my header file and create constants to represent each number so that it makes my game easy to, or my code easy to understand. So I'm going to create those constants. I'm going to say game, what should I call them? Integer values for each game character, because our game is basically a collection of integers that we use to move the, yeah, it's a collection of integers. So let's see. So I'm gonna have const int, and then I'm gonna call the constant empty underscore space, because that's gonna represent an empty space. It's the integer number 0. Then I create all the other constants. So copy this, paste it there, paste it there, paste it there. One more time, paste it there. Then after the empty space, we can have a star, right? So the star it is an integer number 1, right? Then the battery, I'm gonna just call it battery. It is integer number 2. And then the operator, we'll call the constant operator, has the integer number 3. This one is integer number 4, which will be the wire. So that means instead of me initializing my array to 0, I'll initialize it to this constant called empty space, so that my code is easy to read and understand, even for someone who doesn't know code. So how do we initialize this, right? After done allocating memory, right, you could go down separately and go through all the indexes, or all the positions in your array. But that's a waste of time, because you already have a for loop there. So why not use this one for loop to your own advantage? So I'm gonna just use the first for loop. So after allocating the number of columns for each row, I'm gonna go through each of the columns now, because the first for loop already goes through all of the columns. And if you remember our deck, my explanation here, where is it? Oh, I had put it inside the CPP file somewhere there. Where is it? Yeah. If you remember our code, right, at each index, we go through all of the columns at each index. That's why I have a for loop within another for loop. So for int j, I'm gonna use j now here. So j is equals to 0. Or if you are used to informatics, right, you can say R for rows and then C for columns. You can do that. I'm gonna use I and j. So j is less than calls and then j plus plus. And now I have both positions, I have both indexes, the row and the column. You just throw it inside the variables I and j. Then now I can set to initialize my game world to empty characters. So I'm just gonna, for now, just simply yeah, let me show you. So I'll simply say ij is equals to, instead of initializing it to 0, remember I gave the integer value 0 its own name through creating a constant. So now this will actually be empty 0. Empty space, I mean. So that 0 would now be empty space. So now my game mode is filled with zeros, which is basically empty spaces. So let's quickly go to display function before we continue. So I'm gonna zoom out a bit. Let me see. Yeah, let me not zoom out too much, but I need to also zoom in. So I'm gonna have display world, right, which takes in my 2D array that I want to display, and it displays it to the console. So I'm gonna firstly go through all the rows. So int I is equals to 0. I is less than rows I plus plus. Then I go through all of the columns. Int j is equals to 0. J is less than calls j plus plus. Right, so there's my game mode. Then I'll simply do what? C out. I'll display the game. So C out what? Game world at position I j. Because at each position or at each position or each coordinate, because I said we can picture it as like a Cartesian plane. So at each coordinate ij, we're going to display the symbol that's there or the character. Remember, so far we only this output, right? It's going to only output integers because why? This empty space is basically is a constant for the number 0. It means that my array world or my 2D array has empty spaces or zeros because I chose to say 0 represents an empty space in my game. So I'm gonna say C, and then after this, I'm gonna put in. Let me think about it. Do I need a space? Yeah. So I'm gonna output a space there. Why am I outputting the space over here? The space, because if you look at your game, right, if you're displaying zeros, let's say zeros, if you don't put the space is gonna be like this. It'll be squashed together, right? So you need to put a space like this. So that's what this space does over here. Then that space does that, but then if we leave it like this, right, it's only going to output it in one line. So when it's done with the first column, it goes to the next column, it outputs in the same line. So now we have the next column, which is from here to there. That's the next column. But C++ doesn't know that, right? You need to tell it to display it to the next line. We want it to display on the next line when it's done going through all of the columns. So this is my for loop for going through all of the columns. So after it's done, which is basically when this curly brace is reached, that means it's done going through all of the columns. Then I can output an end of line character, right? So that means it's gonna go down here and then end line character. Then if there's another column and then end line character, then we end up having the grid form of the game. And then once I'm done here, right? You see here, right here, this is where you display the movements, right? Like move up, move down, does this. That's where you display them here. So here I'll just simply output an end of line character. Just to, you see, it's important so that it makes my game a bit neat. So let's simply initialize allocate memory for the array, right? By calling allocate method, which is this. Then we code display so that we can see if it's going to display. So that we see something. So I'm going to go to my main. Okay, this is spiritual now. So hash include missed. Oh, it's a capital I. It should be small I. Hash include missed.h. Yeah, spelling is very important. If you capitalize this to an I, it's gonna crash. It won't run. So be very careful. And then we have a namespace called missed space, right? So I need to say using that namespace. So using namespace missed space, right? Then we initialize our rows and columns. For now, I won't use command line arguments. I'm gonna use I'm gonna say use my own random numbers. So I'm gonna say int rows is equals to, let's say 20 by 20. You can get it from the user, that's also fine. But then for this project, I want you to get it from the for this question paper, they want to get it from the command line arguments. So since we are not, you guys are not taught yet, I'm gonna skip that and create just simply initialize them to some values. So 20, 20, 20 rows, 20 columns, and then battery is battery probability. Let's say it's 10. By 10 we mean 10%. So I'm gonna choose a random number. Let's say 10%. What else do we need? Wire probability. Let's say wire probability is a smaller one. So int wire wire probability. It is a smaller one. Let's say it's 8%. Then we need to allocate, right? Yeah, we need to allocate. But then our allocation will return. Remember, they told you about functions that return. We did also have a session on that. So this function returns a 2D array. So I need to create a variable of type 2D array. I'll call it array world. And then this will store whatever is returned by the allocate function. So I'm gonna use call allocate. Is it even picking it up? Oh yeah, it is picking it up. Then you pass in the rows, calls, battery probability, and then wire probability. Right. So I hope we are still on the same page. I'm just passing the things that the allocate function requires. It requires the rows, the calls, the battery probability, and the wire probability. But then that function returns something. So I need to put it in a variable. So now we have our game mode and it's stored inside this 2D array. Then now we call the implement display function, right? So display world, there's a display world function. It takes into 3 parameters, right? One, the game world itself. Okay, let me not say array world, let me say game world. Yeah, because it's my game world. So game world, comma, what are the rows? Remember here, you've declared that it expects an integer. When you call a function, you only pass in the names of variables. So I'm going to pass rows, calls. C++ is going to check what are they really data types of int. If they are, then fine, don't complain. So now let's run this. I should see zeros on my output, right? Yeah, there should be zeros. Yeah, you see zeros. There's my game mode. Let me show you what I was talking about, that if you don't put the end of line character, it won't display, it's going to display it in one line. So that you don't think I'm lying. So let me remove this part over here. After going through each column, let me not display it in an end of line character. You see that it's going to be in one line, one straight line. The thing is to, let me do this. If we zoom out a bit, right, you see, it's in one line. We don't want that. We want it in a grid form. So that's why we put in this end line character here, so that we end the line there once we are done with the last column. So that when we start on the new column, we start the new column on the next line, so that it shows it in a grid form. So that's the reason behind that. But then, do you notice a problem here, right? I'm sure you can see the problem. We are seeing zeros. The user can't play a game with numbers. So we need to actually find a way to convert that zero to a meaningful character or a game character. Remember, we have a one-dimensional array for that, which is somewhere here. Yeah, it's called game characters, right? And you pass in at each index, right? At each position, you get back a symbol. So that zero, that empty space zero, we need to actually use that number zero as a as a input into this index, into the square brackets. That's why if I go back to my display world function, right, where is it? Yeah, here when I'm displaying the world, I should actually, that integer that's returned. Remember, it's an array of integers, right? That integer that's returned, right? Let me store it into a variable. So int let me call it feature. It's a game feature, right? Or game character. Or game, yeah, let's say feature. This returns an integer. Remember those integers. Which integers am I talking about? These ones over here for my game characters. Remember, each game character is represented with an integer. So instead of displaying the integer itself, why not display the symbols? So that it makes it easy for the user. So to do that, you call game characters constant. Remember here, it expects a index or an integer number to extract that specific symbol. So that integer number that I need to pass is just feature. Or you can just simply pass that whole array again in there. So that's why you put it as a separate variable so that it's kind of readable. So you see now I pass in the feature. Then that index, if the feature is a zero, meaning it's the number zero, then it's going to go through the array and it checks, oh, at index zero, I have a dot. So now it's going to display a dot in terms of instead of the number zero. So now you see in my output, I'll have dots, and which makes my game a bit easier now. You see, there's my game. It's a bit easier because now I see there's dots instead of numbers. So there's the game. For now, it's empty space because we haven't we haven't just placed some characters, right? So we need to place the characters. So let's see. Okay, it's almost 8, but it's fine. Let's place the operator before we end the session. So the operator, where's the operator? Yeah, they said the operator is starts at a random column. So that means the in our 2D array, the column we're gonna pass in this integer because we've generated the column. Remember, J represents our column. So that means the second set of square brackets represents our column's dimension. And then the first square brackets, which you're gonna pass I, represents our rows because I is rows. So that means always when we have these two square brackets, the first set of square brackets represents the rows or which row. Then the second set of square brackets represents which columns. Why is that the case? Because that's how we initialized it here. And that's how also initialize the day. We started by rows, then we followed by calls. So let's place the operator. So to place the operator, they said at the last, let's check. They said at the bottom row, right? By bottom row, they mean the last row. If you remember the formula we're coming up with here, when you're talking about, basically the last bottom row is the last index. The formula for the last index is the size of that dimension minus 1. In this case, we want the last index for the rows. So I'm going to say total rows minus 1. So int last index, right? Or we can say the row will be, and notice something here, don't be confused. This is rows in plural. This is row in singular form, which is a single row. So that single row can be found by looking at the total rows in plural minus 1. Then now I can place the operator. Right, let's place the operator. How do we place it? Remember to place, we initialize the array with insert it and give it an integer. So array world. Okay, let me be consistent, right? Instead of array world, let me call it game world because I want to be consistent. Right, so game world, and then game world, and then this will be game world at index. We need to pass in the row here. In this case, I just call it row, so that's fine. Then here I need to pass in the column, right? But then there's no column variable. Which variable stores the column is the random column variable because we generated a random column. Then I pass the random column there. Then I place the feature. I initialize my array to that feature at that location. So it's going to be equals to, they say what's the feature? It's operator, right? So operator constant. Remember, instead of me using integers, I have constants for them. I have names for numbers. So instead of initializing my array to 3, I can just initialize it to the word operator or the constant operator, which just simply means it's 3. But now when someone reads my code, they can understand it. They can see, oh, it's an operator. You're setting the game world at this row, at this random column to that operator. Then now if I run my code, I should see an O in my output, right? In my game world, because I've placed that operator. There's the O over there. And it's to show you that it's in a random location, right? I'll close it and then run it again. You see that it won't be at the bottom anymore. So build and run. Okay, before my bad. Let me go back to main.cpp. I forgot to use the srand function so that it makes it there. We need to make sure that the random function generates a different number every time. We need to do what I call seeding the random number generator. Basically making sure it always generates a unique or a different random number. Then you pass in the time function. Then I'll just simply pass in the time. So in this case, the time will just be 0 or null pointer. You can pass 0 or null pointer there, that's fine. Then let's run it again. If you don't seed the random number generator, it's not going to be random. You see, now it's starting to change the location. You see, now it's there, it's there. And remember, this the question paper said at the bottom row. So it will always be in this row. That means it will never be placed somewhere here. It will always be placed at the bottom row. So I'm gonna go here and then I'm gonna run it again. Build and run. You see, it's still there, but then it's actually in a different location. Let me run it again. Hopefully it's now, yeah, it's now it's at the corner there. So it is actually generating a random location. And it keeps on updating it now because I've seeded my random number generator. So we call this seeding the random number generator. Actually, the S inside this srand word, the S stands for seed, right? Like planting a seed. So this is basically how the game would look. Okay, we'd have to have the do while loop, a while loop, whatever. But then for now, not yet. We're not gonna have a loop yet because we ran out of time. We're gonna have to continue tomorrow. So that's so far we're not done with allocating the game world, right? Remember, we've only placed the operator. We still need to place the switch and the empty pro locations, yeah. And then we need to do some probability handling here. So yeah, that's it for today. See you in tomorrow's tutorial.